Hey there, this is Jenny Chen. I'm the founder of 3D Heals. Welcome to the Lattice podcast, the official podcast for 3D Heals. This is where you will find fun but in-depth conversations with technological game changers, creative minds, entrepreneurs, rule breakers, and more, focusing on how we can use 3D technologies like 3D printing and bioprinting to reinvent healthcare and even life sciences. This podcast will also include AMA or Ask Me Anything sessions, past Instagram live interviews with influencers, and other direct engagements with our tribe. Hey! Always scares me these couple minutes. Just want to make sure everybody can sign on.
Yeah, exactly.
But I'm glad you did it. Awesome.
All right.
Well, thanks for joining us today, Robin. I think we have a couple of audience people are signing up, but I want to start this episode with an introduction about who you are. So Robin is the founder of Addmio, obviously the account we're interviewing today. And you had a actually rather long journey of entrepreneurship. You actually had your own design studio for more than 10 years, maybe even when you were a student, based on the description you gave me. And then after that, you had very extensive work experience in the 3D printing industry. Starting with Shapeways, you say you basically worked with all the polymer-based 3D printers, and then you moved on to Additive Industries, and then you had metal and basically metal 3D printing experience. And then you founded, in pandemic last year, you founded Addmio as the main 3D printing education platform, basically. So why don't you tell us what inspired you to start Addmio?
Yeah, well, first of all, thanks for inviting me, and also thanks for the extensive introduction. Yeah, that's a good question. Even before I started at Shapeways, I already knew that I wanted to start my own company, and I also knew that it had to be like a 3D printing company, because I fell in love with the technology during my studies, during my internship. But I didn't really know exactly what kind of company I wanted to start. And then it sort of formed, the idea formed. I wanted it to be educational. At first I thought about giving training or giving workshops at elementary schools and high schools. And during my career, it sort of transformed into something that became more and more clear and also more and more realistic, because I also wanted to bootstrap my company. I deliberately didn't want to have any funding from a VC or a bank loan at the start. And I think the last thing that really helped me make the decision was that I ran into Kickstarter and read about it and learned more about it, and eventually that's how I started the company. One thing that was really important for me was that I saw this extremely powerful group of technologies, 3D printing, and I saw that it was adopted quite early in Formula One, aerospace, really the industry where you have very high value parts, but also large budgets. So really the industries that can spend the money. And I saw a gap. So I saw these really powerful technologies, and I saw a lot of people that couldn't use it because they didn't really know how to use it or when to use which technology. And then I thought, well, I want to make a scalable platform, something that is digital, so that I can share everything I've learned with a lot of people and make it really affordable.
Yeah, as I was reading your bio, I was like, wow, Robin had the best education anyone can in 3D printing, because you basically worked with all type of 3D printer 3D printing processes. You work with different materials, and with Shapeway, I bet you saw a variety of applications. Yeah, so I'm sure you have more experiences than many of us who, just have one printer at home. So do you see yourself more of a 3D printing engineer, or do you see yourself as a 3D printing designer?
Yeah, that's a very good question, and also very, very interesting that you noticed that, because looking back, indeed, I think this is one of the best starts of a career you can have in this industry. But it's not that I knew it from the start, because Shapeways literally was the first professional company I came in contact with, because I had to order something there. And I saw this website, and I almost couldn't believe how it worked, that I could design something, because I was trained as an industrial designer, that I could design an end product, functional and durable, and upload it and pay like $20 or $30 and have it a few days later. I thought, this is incredible. Why is nobody jumping on this technology? And since they were the first ones, and I was so extremely impressed by everything I saw, I really thought, okay, I want to work at this company. And indeed, looking back, I think for everyone, if you want to start a career or make a career in 3D printing, working as a service provider is so extremely insightful, because you really see the best side of 3D printing. It's real production. Instead of printing one part in your office, what I'm also doing a lot of times, but now you're printing hundreds of different parts every day, and you see so many applications. It's really really insightful. Yeah.
So when did you join Shapeway? How many years ago was that?
I think around 5 years ago.
And since 5 years ago, there are a lot of things changed, right?
Yeah.
From either from design perspective or educational perspective. What are some of the major growths you have seen in the last 5 years for both?
Yeah, I think the market is maturing. That's great to see. Also now at this moment, market is consolidating. A lot of big investments, big companies that are bought. You really see that the machines, like the hardware market, is maturing. The materials are very much maturing. So yeah, the big companies are really investing in 3D printing. And I think what you also mentioned, design, it's talked about, but I think it definitely deserves more attention, because eventually a good design for additive manufacturing or for 3D printing makes or breaks your business case. So I think every company that produces parts, and a lot of different companies that don't produce parts at all, can benefit from 3D printing. And if you take a part that is designed to create in a conventional way, to CNC mill, and you take that part and you send it to a metal 3D printing service bureau, they might charge you $5,000, and then you think, well, this is crazy expensive. This is not a technology for me. But if you take an application and you go back to purely the function, what is really the function of this part, and you really optimize it instead of designing it around the limitations of the manufacturing methods, yeah, then you create incredible parts, things that can never be created in any other way.
So would it be accurate to say that Admios courses right now focus mainly on the design aspect of 3D printing?
Not yet.
Okay.
That will be the next step, because I really wanted to. I wanted to start at the start. So I noticed that a lot of people were a bit, sometimes a bit insecure or a bit scared to get into the industry, because they would see a metal print or a polymer print, and they would think, I could never design this, or I'm not smart enough. And I think that's not true. I think everybody that's creative can benefit from this technology. If you went to college or university, or it doesn't really matter. And yeah, I think that's something I want to promote, because also in my career, um, I was mostly working in teams, and everybody has master degrees and PhDs, which is great because that's also a very important part of the industry. But eventually, you also just need. I mean, you just need to have passion and creativity, and that's enough.
Absolutely.
Yeah.
So, if to give to give a short preview of what you're going to do in the future for future courses, what are some of the major design concepts you think people should learn in 3D printing?
Yeah, yeah. I think, well, I mean, of course, the first things you learn, or the first things you see if you really dive into the design for additive manufacturing, is lattices and topology optimization or generative design.
Mhm.
And yeah, I remember like the first event where I had to speak for Additive Industries. I think that was in one of my first weeks. Um, and I almost felt, yeah, I had the same feeling. Wow, this is so extremely difficult. Maybe I will never learn how it works, but eventually, I mean, the principles are not difficult. But I mean, it just looks sexy. If something is topology optimized, you immediately see, wow, this is futuristic. Um, and I think that's cool, but that shouldn't be the goal. I think for me the best designs and the best applications shouldn't even have to be sold or presented as something that is 3D printed. So I think you should combine um, an optimal design and a very strong business case, and all the advantages, all the benefits that you can have with this technology. So faster time to market, mass customization. And yeah, I mean, now this is exactly. I mean, now we're getting to this terminology that you always hear, and it sounds difficult, but it's not. I think. Well, I mean, let me start over. I think the best designs are the designs that improve lives. That's it. And that's also what I like about 3D Heals, that you really have to focus on medical, because that is really one of the industries that is seriously transformed in a positive way. And you really see applications that improve improve the work that doctors do, because they can practice before they can do a surgery, and hugely improve the recovery time of patients, and then improve the time that they can use or yeah, live with this implant. And instead of having to replace it after 7 years, maybe they have to replace it after 15 years. So yeah, in that sense, I think those are the best applications, definitely.
Yeah, so Robin, I think I definitely echo a lot of passion that you share. Actually, for the design aspect of 3D printing, I mean, one of the reasons I started an Instagram account is because I found so many amazing images of 3D printed lattices and applications on Instagram, including your account. I'm
Thanks.
fascinated with all the applications that you feature on a regular basis. And also along the way, I encounter a lot of names of softwares that I have never heard of, you know, until I encountered Instagram, like Houdini, Autodesk Maya, Grasshopper. I still don't know how those work. And again, I'm also very intimidated by the complexity of this, what it looks like. These softwares are very complex. So it would be great to have some kind of educational platform to learn these tools, because I do believe also that these are the tools of the future. And I know you brought a couple examples from your past design work or 3D printing work. So do you want to show us what they
Yeah,
are?
yeah, of course. Yeah, of course. Yeah, I think that this is a nice example because it. Can you see it clearly? I think so, right?
You can hold it. Yeah, it's pretty good, but you can hold it closer maybe to the camera and can rotate a little bit. Maybe, yeah. Perfect.
Yeah. So here, do you see what it is? Do you have an idea what it is?
This would be a great Instagram and Q&A process. Guys, you guys want to tell us what this is? Can you tell? Okay, you know, I'm gonna take a wild guess. It looks like blades of some sort. Is this a already like finished product, or is this has supports around it still?
Yeah. Yeah. The part is finished, but it should be assembled. So a few components should be added. Well, I can show you. I can show you how it normally looks,
Okay.
and that is like this.
Oh.
Yeah.
Okay.
Yeah.
That's okay. Can you put that back on again? I want to see it one more time.
Yeah. So it's a mouse. Yeah.
Interesting.
Yeah.
Yeah.
But the great thing is, I just took like a lump of clay and I formed my hand around it, and then I 3D scanned it and used it as a basis, and then topology optimized it.
Nice.
Yeah. So it exactly it's made for my hands.
For your hand.
Yeah. 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 And then you also see the materials is quite flexible. So and it's all printed at once. So you have quite a few things here coming together.
Yeah.
And you can literally like shove the PCB in and the electrical components, and it works.
Yeah.
And you just have your own mouse.
That's awesome. I
Yeah.
love that. This is almost again how humans can interact with digital world in a way, right? Because you transform your digital world using 3D scanner, you got the digital files, and then you design the computer, and you come out, print it out, this thing that you can interact with. It's pretty
Absolutely.
amazing.
Yeah, absolutely. And I also picked this one because here I also have it in metal. So this is in titanium. And you also see that there's like an extra level of difficulty because you have all the support structures.
Mm-hmm.
So, yeah, this is so the other technology, the plastic technology, you can print it without support structures. It's a beautiful material because it's strong and it's flexible and durable. But I mean, printing in metal is just something else. It's of course it's a lot more expensive and a bit more complicated, but it's such a beautiful process. Yeah, and people often think that it's not really metal, that it's like 50% dense and you can crumble it with your hands, but it's not. It's really metal, like a metal rails or whatever. Yeah, the mechanical properties are similar to the metal that you see around you or in structures.
So is this mouse designed for a client, or is this a mouse that you designed for fun?
Yeah, I designed it for fun, and yeah, of course. Also, I mean, it's cool to design things outside of your work.
Yeah, no,
Yes.
I mean, I can see so many things just coming out of it, you know, like you can design a mouse for yourself, or you can design a mouse for a disabled person who
Absolutely.
who have
Absolutely.
you know have to have some kind of prosthetics to interact with it, or and then another subject I'm very passionate about, even though I'm not an athlete myself, is the performance sports goods. If you have a better baseball glove, or obviously better shoes, or better snowboard, you can perform better. I don't think it's going to make me an athlete regardless, but it's something that I'm very fascinated with.
Absolutely. Yeah, I completely agree. I mean, things like saddles or like helmets, like that's a beautiful application. I mean, it's so things that are that should fit to your body, like ergonomical designs. They're just so much better if they are optimized for your body and your body alone. Yeah, and often, I mean, if you look at the Hexer helmet, for example, yeah, it's just it's a beautiful design. It looks cool and everything. Yeah, that's the beauty. If it designs or if it combines a design that's just aesthetically so much better than a standard part, and the properties are so much better, and it's completely optimized for you as a person. Yeah, that's the perfect combination.
Yeah, I think people are oftentimes were first drawn to the aesthetics of 3D printing because
Yeah,
I don't know, for some weird reason it's so pretty, but more importantly, there's also functionality. That I think that's more important down the line. Um, yeah, how do you balance the two?
yeah, that's a good question. I think the aesthetic side definitely helps, and it also uh, there's a reason that most of the designs look aesthetically more pleasing, and that is because often you have organic shapes, and the reason therefore is that if you design for 3D printing and you're optimizing, so you want to use the least amount of material as possible, then you do that. Then you do it based on the forces that are applied on the parts, and then you remove all the material that is not necessary. And that is not something that we came up with as humans, but it's purely based on nature. That's also how nature works. Yeah, if you have a tree and the wind blows from one side all the time, then the tree gets stronger on that side, and that's also yeah, that's also how it works with optimized designs.
Do you think we can ever be more optimized than nature?
That's a very interesting question. I'm not sure. I'm not sure.
Where is the limit?
Yeah, indeed, indeed. I think we still find examples in nature every day that we cannot mimic yet because of the skill or complexity, or we just don't understand it. So no, I think nature does a way better job than we do at the moment.
So speaking of optimization, I want to ask you a question about the difference between, let's say, we have a home printer doing prototyping versus production. What are some of the things that you think people should care about in terms of design?
Yeah, that's a good question. I think if you yeah, I think one of the cool things is that there is not always a big difference, because, for example, the printer you see here, I bought it for I think €100, and it's really a good printer, and that was not possible five
And what
years
printer
ago.
is that? We want to know what kind of printer only costs €100 and that's pretty good.
Yeah, I think it was discounted back then, so maybe it's 130 or something now. But it's the Monoprice Mini. I don't know if I can make.
You can, that's fine. We're
Yeah,
just
okay.
users.
Yeah,
Yeah.
yeah, it is. And I mean, I've worked with low cost systems, and of course also with expensive systems. Yeah, I think they all have their advantages. Yeah, I think as soon as you work with the technology and materials that are really expensive, then you just invest more time in the design process, because eventually that's worth it. And if you have a printer of €100 and you have material that's $15 a kilo, yeah, then you can just prototype whatever you want and you print a few extra to hand around. So yeah.
Well, in a way, the lack of need. I mean, I think there are some printers who are bigger, may need some kind of production design, like to stack things up perfectly. But the fact that, just coming from this conversation, that you don't always need to optimize design for production versus prototyping, it's a good thing. I think it's a good thing. Because that means that file can be used anywhere quickly. And all you have to do is just have more printers, and then let the robots do the work and become production. So it's interesting to know. There's always different opinions about things. I think it depends on like what kind of printers you use.
Yeah, yeah, absolutely. I think indeed that's what you see now. That if companies want to scale up production, then you often see that they just buy more printers. I don't know if that's the way to go necessarily. I think eventually manufacturing is changing quite rapidly, and we're going to, instead of globalization, we're going to localization, where you only print what you need and you also print it as closest to you as possible. And I think that's really a good trend. Yeah.
Okay, so we have a couple of audience questions. One is asking, do you build your support structure in CAD?
That's a very good question. Sometimes I did. If it's really complex, and especially if it's large, then you often combine CAD supports with supports that are generated in the build preparation software. The best designs are designs where the supports are integrated, that don't have support at all. And that's not always something that you can do, but that as a designer for AM, for additive manufacturing, that should be your goal, to really, really minimize the supports. Because it's sacrificial material, it's waste, and you just want to minimize the waste, and it adds to your process time, because it needs to be removed by somebody.
Yeah, that's a good question. And then there's another question that says, how do you get the design? I'm assuming the design of your mouse.
Yeah, so I started with a lump of clay, formed my hand around it.
Can you show us again? Someone is asking, can you show us again? It was awesome.
Thanks. Yeah, so it's based on a lump of clay that I 3D scanned. And then I literally put the forces that are applied from your fingers. I imported them into the software, and then the whole lump of clay is removed, except for like the finger pads and a few small organic structures.
Is the flexibility of the pad, I mean, in addition to just the shape of this mouse, like those are also considered, you know, how quickly you can click on it, or is this having some kind of tactile response to things?
Yeah, definitely. But that's eventually, I mean, you can simulate a lot of things and calculate a lot of things.
Sorry, something just dropped.
No problem. Are you okay?
Yeah, I'm okay.
Okay, great. But eventually, I'm a big fan of just like print it and try it out. That's the beauty of 3D printing. You can design, you can sketch something in the morning, and you design it in the afternoon, and you print it, and in the evening you hold it in your hands. That's beautiful.
Yeah, but I want to say, guys, this is like after 20 years or maybe 10 years of serious design work. I want to do the same thing, Robin. Can you teach me how to do it? Because that's everybody wants to do. So how can we transform our ideas into a physical form using 3D printing?
Yeah, it's a very good question. I would love to focus more on educational content for design, absolutely. But I just want to nail like the basics really good, because it's so attractive for me to skip the basics and go to the sexy design part. But
yeah,
I want people to learn like everything that's necessary, and then we get to the good stuff.
Yeah, exactly. I think it is actually amazing that the basics are not really well educated to the public, even universities, right?
Yeah.
And you're in Netherlands right now. You're in Amsterdam, right?
No, in Eindhoven.
Oh, Eindhoven. Okay.
Yeah.
I mean, where do people in Netherlands get, or Europe in general, gets their 3D printing education? Let's say if you're a college student and you want to get a degree.
That's a good question. I think, well, most of the technical universities have 3D printing labs and have sometimes minors or sometimes even masters. Yeah, I think that's coming up now, but yeah, that definitely can be improved. I mean, yeah, I think it's getting better, but I also see that it's difficult for educational institutions to really keep up, because developments are changing so fast. I mean, industry is going really fast. And one of the things also, I'm sorry to bring it to you, but the best case studies, the best applications are in most cases not shared with the public because they give the companies that develop them competitive advantage. I mean, the things you see on the internet and on trade shows, that's probably a selection of 5%, and the 95% that's probably even better and even more interesting is often not shared.
Yes, I agree with you. So, I have friends, period. SpaceX, for example, they have their internal 3D printing team, and Apple has their own internal 3D printing factory. I don't know exactly what they do with them. Maybe I do, I just can't say it, but they do have it, and they've been using it, and there's a reason why they paid more to get more. So I believe that. I think that's a good thing that people keep in mind. There are a lot of things that we don't really know that's happening, is undercurrent, and it's coming. And it is good to start to learn this technology from the bottom up. I think we have maybe one last question. I think one person asked a question. I think the relevant question is, if you're going to start to learn a process, FDM, DLP, SLS, which one would you start with?
I would start with FDM because it's safe to use, it's really easy to use, affordable, and it has quite some similarities with more expensive materials because I do have an example here. So this is printed on the 100 euro printer. And the thing is that you still need to define orientation. You still need to add supports in many cases. So you really learn the principles also of other technologies that are more expensive and more difficult to learn.
Awesome. Well, Robin, thank you so much for having a conversation with me today. Hopefully we can do this again. And thanks for the audience for asking all these great questions. And we will see you soon.
Perfect.
Okay.
Thank you so much.
Bye-bye.
Bye.
That's it for this episode. Be sure to follow us on Facebook, Twitter, and Instagram at 3D Heals, and check out the links in the show notes. See you next time.